touch and see. For example, mouse, keyboard, printer, scanner, internal disk, even disk also. Disk also, if you remove hard disk, if you remove, you can touch it. That's a peripheral. Okay. But software, can you touch and see? No. Can you touch and see your C program? No. So that is not hardware because you can't touch and feel that. It's not a peripheral. It's not physically existed. Okay. But if this is, operating system is a program, but we can't say simply it's a program. It's a special program. It's a system software. That's why we are calling operating system as a system software. Not a normal application software. It's a system software. Why it is system software? Because when you write the program will communicate with the user application. Okay, for example, you bought a new laptop. Okay, you installed some video player, music video editor, and some your programming applications, C, Turbo C, C++, and you installed some browser. Okay, and you installed some graphic designer tool. All these you installed. Okay. Now Word, PowerPoint, Excel, music editor, video editor, whatever I said, all those are application software. All those are application software, not system software, because it will not communicate with any hardware. Communicate means what? It will make the hardware to work or to stop. It will control this software, operating system, that will control the hardware. But your application software will not control the hardware. Application software, whatever I said, C, Java, Word, music listener, editor, browser, all those will not communicate with hardware, will not capable to control hardware. But the operating system, even if it is a software, it is capable to control the hardware. Control the hardware means it can decide when the memory should be allocated, for which device or for which user. Okay. To clearly understand the operating system, if operating system is not there, what you can do? If it is not there is no operating system. If no operating system, generally we will call that as an embedded system. For example, our refrigerator, microwave oven, drink, beverage vending machine, all those are also computing device, but all those devices we will not say as a computer. Okay, though it performs computation, we can't say that those are electronic devices. That's it. Okay, those we can call as an embedded device, but some of the embedded device may have operating system, but generally embedded systems will not have operating system. If you take a simple toy, okay, there is a toy. If you turn on the switch, it will sing a song. And the song completed, it will automatically turn off. It's an embedded system. It's not a computer. Okay. But here, how many operations are possible? There are many things doing or what? You can do with that electronic toy? No. You have to do just turning on to sing a song. It will do that singing and then it will turn off. Very less, no complex operations. Here there is no need of operating system only. No need of operating system. Students, you all should listen. I will ask the question. After every lecture, I will ask the question. Remember, you should listen. Okay. Are you all listening?
Yes, ma'am.
Yes, ma'am.
Okay. So there is no need to, in that time, you no need to spend for operating system. No need of operating system. Okay. There is a microwave oven. So in that oven, what you will do, you will turn on and you can set the mode and you can preheat. So all these single task at a time you will do. So there is also no need of operating system, because now I am trying to make you to understand what is the significant, what is the important of operating system. So for to know that, you should know without operating system what is not possible. In some of the cases, operating system is not required because there is no multi-processing there. Multiple process at a time, wherever comes, there only we need one manager. That is our operating system. For example, nowadays, simply you are opening the laptop and you just listen the song using some application, and you are opening the Word file, you are typing it, okay, and you are saving the file. So how many, see, you are listening the song also, and you are doing some other work also with some other application. For example, you're typing your C program and executing it by listening the song. So there are more than one application simultaneously working here. How it is possible? Because both the application should may need input device, output device, memory unit. So there should be some broker, no, there should be some mediator which should we can say manager, which should manage all these tasks. Okay, first you started music application, so there should be some memory or device or the respective speaker or something should be connected. Okay, but at the same time you started to type the Word file. So you're giving input, your keyboard is working here. Okay. So when you give input to that, you are typing character A, B, D, and all. So that is simultaneously should be stored in the memory. So how many things you are doing at a time? So all those are different applications. All those required peripherals, hardware peripherals. So, okay, this is only this memory space you can use, Word can use. Okay, rest of the memory should be used by any other application. So all these are decided by whom? By the operating system. So wherever more than one number of tasks or processes are getting processed, there we need operating system. Okay. There are operations which are fixed one after another only will be executed in the same sequence. Then there is no need of what? Operating system. Okay. Without operating system only, because at a time any one system, any one application will work. Okay. So that application will only use the available peripherals, the available memory, everything. And after used that application, you will close. Then only you will open another application. So the whatever memory and peripheral used by the previous process now will be released. Now everything is free. Then the second application can say use all those peripherals, whichever needed. So there is no need of manager. There is no need of operating system there. Okay. When the operating system is needed, whenever the multi-programming or multi-processing is there, we need the operating system. There is a need of operating system. Okay. Now as per your syllabus, the subject name is Introduction to Operating Systems. Okay. And for that, you have to refer Modern Operating Systems by Tannenbaum, third edition. Even you can refer fourth also. Okay. Again, this this book is very vast, like web programming only. This also, this is very vast. This will have so much of content. Okay. We are going to follow only the whatever is, because our subject name is Introduction to Embedded System. Okay. But this book has all the concepts in depth about the modern operating system. Okay. So just we are going to keep this as a textbook, but of course you can refer whatever I'm teaching, what are the points I'm saying, that will be there in this book. Okay, but more than that also there. Okay, so it is very important. You have to put set notebook for operating system. You have to take simultaneous notes. Notes means what? It's shortly, however you will understand. You will write the points. And the end of the day, you have to make that as a notes and you have to keep with you. This is very important because this this book is very vast. So without doing that, if you start to study that book, then you will feel what to study, what not, what you have to leave. So listening the lecture and noting down all the points, important points, whatever I said, with the topic wise. And after completed the entire day, you have to recollect whatever I said and you have to make a note. This is very important. I'm saying this very seriously. Otherwise, you will only suffer. Now itself, I'm saying you will suffer. Okay, when I conduct any internal exam or even for your semester and all, it is very difficult to study if you did not do this. Formally, I'm saying this you have to do. If you do this, you can score more marks in operating system. Okay. See, generally, what is the advantage of noting down when you are attending lecture is it will save lot of time. Okay. You did not concentrate on the lecture. Okay. I'm saying, okay, next week I will conduct the exam. What you will do, you will start to search materials. You will call to your friends, ask what ma'am taught, and the friend will also not give full, complete information. She will say, I also did not listen, or only this material I have. Okay, everything, the clear, complete material, anyway, one friend will not give you. So you have to call another one. And then you have to search whatever material I uploaded. All these are what completely wasting time, which is very smart way to study. Listen the lecture very keenly when teacher is teaching and take the notes. And at the end of the, because you are attending many lectures at a day, many subjects. Okay. So this is very important at the end of the day. For example, today till 5 o'clock you're having lecture. Okay. Till 5 o'clock, when you spend time sitting in the lecture, you have to concentrate completely on the lecture. This will give benefit because later you no need to search the material and the getting confused, mess up, and then on the day of the exam you will say, ma'am, I went completely blank. Of course, that will only happen because you did not attend the lecture attentively. You just pass the time. Okay. So attentively attend the lecture and make the notes, and end of the day, till for example till 5 o'clock you are attending the lecture. After that, you don't sit. You stand up and do all the work, whatever you want to do, everything. And then again, 8 o'clock at least. 8 o'clock, all the material, whatever you wrote, that in you, because when you're taking the notes very quickly, you have to note. Okay. So next day, if you see that, you may not recollect that, because that day, next day also, you might have attended many lectures. Okay. So 8 o'clock every day you have to sit and you have to just recollect. It's not study. I will not say you have to study. You just recollect all the, when you see the notes, that day you can easily recollect if you listened properly. Okay. So complete sentence may whatever you understand, you write and keep. That's it. When you write, always when you recollect and write, again you will remember. So that's it, that your study is over for that day. Do this as practice regularly. Then everything will be easy for you. Okay. So for operating system, you have to put separate notebook and remember every day maximum as much as possible. I will ask the questions in between. After I started to ask the question, you should not leave from the meeting. All those are very silly things. You should not, you all are grown up, you should not do that. Okay, leaving from the meeting. Leaving from the meeting, when you leave here, it will come, so and so is leaving in my screen. That is only very shameful. Okay. Piyush, please mute. So this you do, just 1 week you do this and see. You will also get complete satisfaction. And what, if you do this regularly, you will not miss the lecture. Many of you are saying, ma'am, morning you kept the lecture, I slept. That you will not do only. Because you are committed with that work. So next day, okay, today also I have to listen. Today also I have to note down whatever ma'am said, ma'am is saying. If I did not understand, I have to ask ma'am to repeat. So all these you will be very, when you're sitting in the lecture, that time is completely 100% you will utilize. Then all other day remaining time you can you can do whatever you are interested. You don't need to keep the book and I have to study. You don't need to say that, because attentively you attended the lecture. So rest all time are on your hand. Whatever you want, you can do. You can spend. Okay, please follow this. Okay. So what we saw, now you understand what is operating system to some extent. That means you will able to compare application software with this system software. Application software, of course, Word you are using, MS Word, you did not create that. Okay. Already the application built by somebody, programmed by somebody. You want to write the document, that's why you installed. Okay. So that is application software, because user software we can say. We can also say user software. You want that, you installed. But operating system, it is not like you want, you can, if you want to use all other application, Word, Excel, PowerPoint, music player, browser, all these you want to work, for that base is what? Our operating system. You have to have operating system to install before installing all these applications. Okay. So without having any operating system, can you install all this? No, it's not possible. Because operating system is a system software which will handle all these application softwares also. The operating system will not do only one function. So that's why this entire operating system, you're going to study about the yes.
Are you screen sharing?
It's not shared.
No.
Already. One second. One second. When I share it, now I'm trying to share the, it is not visible. Yes. Okay. 1 second. Hmm. So the first one, this note down Tenenbaum is your textbook. Okay. And then what is operating system? Modern operating system has these other things. One or more processor. One or more processor we call dual core. Okay. So the processor is single processor, but it will act as multiple processes. Okay. Act as multiple processes means what? Multiple execution you can perform at a time. Okay, that's why here one or more processes. So what are the components of computer? That's what we are seeing now. One or more processes. We have main memory. Main memory is also called as RAM, random access memory. You might have heard. Students, what is the difference between RAM and ROM? Read-only memory and random access memory. Anybody knows? Which is volatile? RAM is volatile. Yes, RAM is volatile. What does it mean? Okay, it's a temporary memory, which is RAM is a random access memory, is a temporary memory. Okay, it's a volatile memory because if the power went off, the data will be lost. You will not have any data whichever was there before. Okay, so it's a temporary memory, RAM. But we are calling that as a main memory. So you may ask, ma'am, you're saying there is a memory, but it is a temporary memory. Then what is the use of that? Because memory is storing the information. So it should be permanent. You're saying RAM is temporary. Then what is the use of that? Any one of you? How can we use a temporary memory? Correct. Correct. See, when you do some task or when you are doing some arithmetic calculation, okay, A plus B into C. So this is the arithmetic operation. Okay, inside A variable you stored something, B under B also, inside B also you stored some value, C also having some value. Okay, so when you perform the arithmetic operation, you will perform, you will get many intermediary results. Okay, so those intermediate results are very permanent. You don't need to temporarily store that. Okay, so that can be stored in temporary memory. Or otherwise, when you open any application, you're performing some task and then you're closing it. Okay. But in between, when you're opening the application, you are working on it. Okay, you consider that's a task. In between, the system hang up or the power went off. Okay, what will happen? Again, when power came, it will start. It will be started. Okay, that time the application, for example, you open your task was prior before this. You open the word, you typed half of the page, but you did not save it. Okay, so what will happen when you turn off? If you did not save, because the thing which you did not save will be there in the register, will be there in the temporary memory. Okay, once you closed that or it turned off automatically, the entire thing will be lost. Okay, so like this, when you execute any task, there are many temporary data you have to store. That is no need, that those data are not needed to store permanently. Okay, so those data will be stored in RAM. So when you execute something, the related temporary data will be stored in RAM. Okay, so main memory is there. We have disks are called as secondary memory. This is main memory, this is secondary memory. Okay, we have printers or output device and various other input output devices. All these are what? Hardware peripherals. So there are so many peripherals if you look at a single computer. So managing all these components, you need a software, system software, which is called operating system. Okay. Why we need operating system? Because the general purpose computers have so many hardware peripherals. So to manage all these peripherals, we need what? Operating system. Okay. Now, where actually the operating system will be in your computer? Where actually it will be located? We can say operating system as an interface. Why we can say operating system as an interface? Why? Because if you look at the system, in the bottommost layer, there are hardware. For example, you connected printer, scanner, keyboard, mouse, everything will be there here. Even this graphic adapter, everything, all the hardware will be there in this layer. Imagine, okay? All the hardware peripherals which you connected externally will be there here, okay? On the top, we have operating system because operating system will directly control the hardware. Okay, this is software, but this software will control the hardware. Okay, how you may ask, ma'am, how it's not clear how you're saying operating system will control the hardware. See, whenever you add any peripheral, for example, you add keyboard, you add new mouse, or you add any scanner with your system, with your computer, you will add, but the processor need two more things whenever you add a new peripheral. One is device driver. You might have heard driver. Device driver is a software. And device controller. Device controller is a hardware. Modern systems has all the device controller, possibly which, because they know, no, that's why we will say that, okay, this particular peripheral will be supported by your laptop or not. Why we are saying this particular new peripheral can be connected with your laptop or not, which means your laptop by default it should have controller to support that particular peripheral. Please try to understand. So device controller is a hardware, device driver is a software. These hardware and software is required for each and every peripheral which you add newly when you add with a laptop. These two are required. One is software, one is hardware. Of course, hardware will be there. It is inbuilt. Okay, that device controller. But device driver will be there in the operating system. Device driver is what? That particular device का software. Okay, the device which you added, no, that device का software will be there in the operating system. It has to just call that after you connected the device, no, it will call whenever we use that particular device, the device driver will be called by the operating system. It should be enabled, that's it. Already it is available. It should be enabled. Okay, so you did not connect only any printer with your laptop. It doesn't mean that your laptop will not support connecting the printer. You did not do it. But when you do, that particular printer software will be enabled automatically. Okay, so that you have to remember. So that's the operating system. So operating this way, through the device driver, the operating system will control each and every peripheral or hardware you connected. Okay, so here in the top bottom most is all the hardware, and on top there is a operating system. On that we have a user interface program. User interface program means what? For example, if you load any application, MS Office, for example, MS Office will have its own interface, no? When you open, okay. Operating system will also have interface. Remember, what's that? After your system booted up, no, you will see the screen. You did not start any application. Okay, you just turn on the computer. Okay, by default there is a screen. That is a user interface. Sorry, that is the interface of operating system. Okay, that default interface, operating system interface will be visible. That means Windows. The Windows default page will be visible. That is called the interface. So operating system will have interface. Each and every application which you loaded will also have interface. Okay, through that interface you will communicate with the operating system. So here there are few applications. For example, assume that in my system I have web browser, email reader, music player. All these are what? Application software. Application software, user interface for that application software, operating system interface, because operating system has many layers. We will study that. Okay, one of the layer is user interface. Okay, operating system user interface. Okay, and we have software drivers as one layer in operating system. Okay, there are other layers also. Okay, so operating system will have many layers. Okay, one of the layers is interface, operating system interface, and then the all other layers of operating system, and then the hardware will be there. Look at here. Here all these are what? Including operating system, everything is software. Okay, except the bottommost one. Bottom may what you have connected the hardware. And look at this side. There are two mode. What is this? User mode and kernel mode. This operating system will work in two different mode. Okay, but at a time either of the mode. Okay, for example, user is executing the program. You are executing the program. Okay, when you execute the program, now you have to understand line by line your program. First, you may write, you might have imported some libraries in your program. In your program, students, you can assume C program. Okay, so now C program is going to be executed by the system using operating system, assume. Okay, so the first statement is library files. Okay, those library files are there because you installed the necessary software which is required for C. So the library files will be there in the operating system, that will be called. Okay, Now this one operation will not require will require only memory, will not require any input output devices. Okay. So now where we are trying to understand the mode of the operating system. Now during this operation, the operating system will be there in user mode. Okay. Because there is no use of any external hardware. So operating system will be there in the user mode and it will serve for the user application whichever they are using. Okay. But the moment in your program there is an input statement. I am saying example. Okay. So there are many statements which will directly communicate with hardware. I have taken one of that. Okay. So assume that there is an input statement. That's the second statement in your program. So input statement which you want a keyboard, no? Okay. To execute you have to give input. Okay. So assume that the input you did not give the program inside itself. Dynamically you have to give. Okay. So it will come and ask, enter the value of A, variable A. You have to enter, no? To enter what you want, you need a keyboard. Okay. So using the keyboard, you will enter. Now here the program which is written by the user, that only has that input statement. Okay. And the hardware, which is our keyboard. Both in between these two, that should be a layer. Because if the user program can directly, without any operating system or any security layer, if it directly control the keyboard, that means the hardwares are very precious, very costly. Okay. So if our user program intentionally can spoil the hardware. Okay, such a way you can write the code. Okay. So that should not happen. For that, now when it is executed, the read statement, that means input statement is getting executed, the input statement will be created by any of the software, for example, C compiler or something like that. Okay. So that software should send the system call to the operating system. System call, that should be called a system call. What is system call? I want to use the hardware. Okay. So the operating system will go and see that hardware is free or it is free to connect with the connect as an input device or not. Okay. Then it will, by taking the system call from the user application, the operating system will move from the user mode to kernel mode. Now the kernel mode is secured mode. Okay. So when the operating system is working in the kernel mode, no other functions, no other application will send any command to the operating system. Operating system will go to one secured layer. You imagine like that. Okay. It will switch to kernel mode because it has to verify, it has to directly communicate with the hardware, which is our keyboard. Okay. So whenever the hardware communication is necessary, the operating system will actually operating system itself will not go to kernel mode. It will send the processor to kernel mode. That is only actually happen. Okay. So the processor executing the user instruction, and then when any system call happens, then the operating system will make the processor to move to kernel mode. Okay. When the processor is being in the kernel mode, all other applications should be stopped temporarily. Stopped means what? Suppose application which are currently need any processor, that cannot use the processor, because now processor is there in the kernel mode. Okay, which is safe mode. So coming into the kernel mode, it will serve whatever. Suppose it has to assign the keyboard, and then it will move to again user mode. Okay. So that is also work of the operating system. So operating system will get the system call from the user application, and it will tell that to processor or microcontroller. You have to communicate with the hardware device. So the processor will move to kernel mode, and then after completing the work, again the processor will be available for other applications, user application. Okay, this much here you have to understand in the introduction. This I said why, because to understand the user mode and kernel mode. So locating the microcontroller in user mode and the kernel mode will be the function of the operating system. Okay. Next, there are two different views of operating system. Two different views of operating system. What is that two different views of operating system? See, the operating system is a interface between what? Interface between, look at the previous this. Operating system is an interface between the hardware and the application programs, application software. It's an interface. Okay. When application programs looking at the operating system, because application programs nothing is transparent. It will not understand anything of the operating system. Okay. So when application programs means what? For user, you are only using the applications, no? For example, Word, music player, and all, you are only enabling. Okay. So for user applications or for users, the operating system is a beautiful interface. That means no complexity at all. Okay. But when hardware is looking at the operating system, which is a bottom up view. Okay. So hardware is looking at the operating system, it is very complex. It's very complex because operating system should handle many things. For example, more than one number of processes are there. Then for allocating resource for each and every process, hardware peripherals and memory also it has to split and allocate for all the running processes. So all those are very difficult with respect to hardware. Okay. So that's why very funnily they said it is an ugly interface. It's not actually ugly interface. It's very complex interface for hardware. So when application programs, now when I'm asking you all, because you are application, you are executing the application programs. How the operating system is, you will say, wow, it is very helpful, ma'am. Because of the GUI operating system only, easily we can what? We can use any of the application because you will not know what is the complexity inside it. Okay. So for application programs, it's a very beautiful interface. This actually just funnily they said. For hardware, it is operating system is very complex interface. Okay. So what they are saying here, in another word, actually technical word, the operating system as an extended machine for what? Application programs. Application program will say, see, when you think, you will imagine, okay, operating system is a hardware. See, generally, if anybody knows anything about, does not know anything about the hardware, no, if you go and ask, that could be any, that could be the operating system should be hardware only, like that they will say. Okay. So for them, operating system is some extended machine. Okay. There is a computer, CPU and all, but operating system is something, some extended machine. They will feel like that. Okay. So that's a kind of view for the application programs. So when application programs look at the operating system, application programs may feel that, okay, operating system is some extended machine. Okay. But hardware, or one second, when the hardware looking at the operating system, hardware will know that operating system is a resource manager. Okay. For the hardwares, operating system is a system resource manager. That resource means what here? All the resources, all the input output data and all the peripherals for everything will be managed by the operating system. So it's a resource manager for hardware. But for application programs, the operating system is some extended machine. Okay, so these are two different views of operating system. So from where you are looking at, okay, top to bottom, it's a what? It's a extended machine. Bottom to top, it's a resource manager. Okay. So now here, we may call the top to bottom view as a abstract view because that's not original, no. For application programs, it is giving some illusion which is not original. Okay. But actually operating system is very complex. It's not a machine, it's a software. Okay. So some illusion, some abstraction, some abstract idea the application programs are getting about the operating system. So you can also say for application programs, operating system gives some illusion or abstract image. But for hardware, the operating system is the original one because what actually the operating system is doing, it is managing the resources, managing all the resources. Okay, so that is the original view. Okay. Okay. Okay, Nikhil, can you unmute? Nikhil.
Yes, ma'am.
Nikhil. What do you know about operating system, Nikhil? What is operating system? What did you understand about operating system?
It is the interface between hardware and software, ma'am.
It's an interface between hardware and software.
Yes, ma'am.
Okay, operating system is a hardware or software? Operating system itself is hardware or software? Nikhil. This operating system is a hardware or software? What happened? No answer.
Software, ma'am.
It is software. Okay. Then application software, it is the application software or any other software? Can we say operating system as a application software? Nikhil, you said operating system is a software, right?
Yes, ma'am.
It's application software. Dinesh Kumar. Dinesh Kumar, you can unmute. What happened, Dinesh Kumar? You are there in the meeting, but not responding. Dinesh Kumar. Okay, Supreet. Supreet, can
Yes,
you
ma'am.
unmute?
Yes, ma'am.
What did I say about operating system?
मैम ऑपरेटिंग सिस्टम आपने बताया कि अभी भी सॉफ्टवेयर सिस्टम मैम एक मिनट हेलो हाँ मैम मैम ऑपरेटिंग सिस्टम मतलब एक सिस्टम सॉफ्टवेयर है ये अपना मतलब
Okay.
अभी पूछा था क्वेश्चन
Okay. Why it is system software, Supreet? Why it is not application software?
क्योंकि मैम मैम इट मतलब मैम वो हेल्प करता इट बोलते हैं मैम उसको मतलब हार्डवेयर को फंक्शन करने में वो हेल्प करता है ऐसा है
Okay. Okay, fine. Chirag. Chirag.
Hello.
What is the top-down view and bottom-up view of operating system? Chirag. Top-down view and bottom-up view of operating system. Yes.
Top down is a beautiful abstraction, and bottom down is ugly interface.
Why? Why it is so?
Because of GUI.
Because of GUI, you did not listen the lecture, right? Karna?
Yes, ma'am.
Karna Bhosle, yes. What is the top down and bottom up view of operating system?
Ma'am, the top. Ma'am, can you repeat the question?
What is the top down view and bottom up view of the operating system? Top down, bottom up.
Ma'am, the top down one is hardware, and bottom up is application programs.
So you also did not listen clearly. Did not understand actually. Ishwar, can you unmute? Students, after I called, immediately you have to unmute and answer. If you take more time, I will remove you from the meeting. Thinking of that, you just turn on, you logged in and you went away. You're not sitting in the place where the system is. Okay, Ishwar, what happened? You're there in the meeting, but you're not responding. Drishti? Drishti?
Yes, ma'am.
You can say about bottom up and top down view of operating system. What happened, Drishti? What did I say about top down and bottom up view of operating system?
Top is an application program.
Top is application programs. Of course.
And
For application programs, what is operating system? For hardware, what is operating system?
bottom is hardware.
Bottom is hardware. That's okay. But my question is different. When application programs looking at the operating system, what it feels. For application programs, what is for operating system?
I'm not getting.
You did not listen. Aishwarya Thomas.
Yes, ma'am. Same question.
Yes.
Ma'am, top down is the way that application programs look at the operating system as an extended machine, and bottoms up is the way hardware looks at the operating system as a resource manager.
Good. Now, Drishti, can you say? Drishti. Students, again I say, and I will not repeat this for each and every lecture. In between the lecture, I will ask the question, you have to answer. Okay, otherwise I will consider you as absent for that lecture. Okay. And you know that in this semester, we will conduct the PTM, parents teachers meeting. So we will show your entire attendance and your internal mark scores, internal or otherwise the general class test if we conduct, that score and all will be shown to your parents. Okay. So attentively you have to attend the lecture, and here after this is the first lecture I'm leaving, otherwise I will not. Okay. So you have to listen the lecture. When I'm asking the question, you have to give the answer. You don't think that you can search in the Google and give the answer, because definitely in operating system, if you search something and whatever I explained may not come. Okay, so by seeing the Google result, if you say the answer, I can easily find out in this subject. Okay, so after I ask the question, by taking some time, if you Google it and if you answer, I can easily find out. That's not possible, especially for this subject. Okay, so you have to listen and you have to answer. Okay, now 15 minutes break you can take. Okay, till 1:30 your lecture. Okay, 1 o'clock you can join. So half an hour I will take and then I will leave. Okay, you can take 15 minutes break. Um, the operating system allow multiple programs to run at the same time. Okay. I said that because of this process only, there is a need of operating system. Okay. So operating system allows multiple programs to run at the same time. Okay. So when we see that there are multiple programs, here programs you can say, you can think here it is a process. Okay, process means what? Typing on the word, MS Word is one process. And when you save that, it will create another process. So one application will create any number of processes. Okay. And hearing music will also create a process. Okay. So now you can easily imagine allow multiple programs or processes to run at the same time, manage and protect memory, IO devices, and other resources. IO devices means what? Input output devices. For example, keyboard is an input device, mouse is an input device, scanner is an output device, joystick is an output device, printer is an output device. Okay. So it is used to protect memory. Why protect memory? When it is storing the data, for example, one application, more than one processes. Okay, more than one processes are getting executed at the same time. So one process is using a particular memory location. The another process will overwrite on the data which was written by another process. So there will be a confusion there. Okay. So for each and every process in a multi-processing system, the space should be allocated for each and every process. That's why through that we can protect memory. Getting it? Memory means what? Students, now imagine main memory. Okay. In the main memory, there is a variable which is stored by one application. Okay. Another application is also want to store data, but it does not know that already there was a data stored. Okay. So it will overwrite on the same cell of the memory, same space of the memory. So the data loss will happen for the previous process because it wants to retrieve the data. That's why it's saved, no? So that is, so this the operating system will avoid that overwriting. Okay, so through that it will protect the memory. IO devices. When input device should be connected, because the whole time we will not use joystick even if we connected. Okay, whole time whenever we are using the laptop, we will not connect with the printer. Okay, whenever it is required only we will use. Okay, so IO devices, how it will how IO devices will be managed by operating system. When any IO request comes, for example, keyboard is sending the system call. Okay, so the operating system should tell to the processor, that telling and communicating, no, that we will see later very elaborately. There are many types of communication. Okay, so the processor should say to the operating system should see that the particular input output devices are free or ready to communicate or what. And before communication, there should be a signal, because whether you are going to read the data or write the data. So all those information should be conveyed to the IO device, okay, input output device. That will be done by the operating system. And other resources. Other resources, when you connect with any network card, okay, or any adapter you're connecting, so that time and all that, those are called resources, or any other communication interface. For example, RS-232 wire you're connecting, or there are many communication interface. So any other supporting, other than input output and memory device, other devices when you connect, that will also managed by operating system. Okay. So when we say the operating system, students, this is very important. When we say operating system manages many resources, okay, that will manage resources. That means that's called multiplexing. Multiplexing is nothing but sharing the resources among many processes. You know what is resources? Resources are hardware resources and software resources. For example, video adapter is a device. Okay, it's a resource. And the printer is a resource. Keyboard is a resource. A plotter is a resource. All these are hardware resources. What is software resource? Data. For example, you have using one application that has database. Okay, so you are saving the data in the database. So the database is also a resource. Okay, not only the peripherals or hardware devices are resources. Here, resource includes everything: hardware resources, software resources. Okay, so when here very big count, this challenge is when more than one number of processors are using the resources, there should be a competition, okay, to use the resource. I also want to input device, you also need input device. Where to whom it will allocate, operating system will allocate. Okay, so that is called multiplexing. Multiplexing, single statement sharing resources is called multiplexing. What is multiplexing? Sharing resources. Students, many terms new terms we will study. We are going to study multi-programming, multi-processing, multiplexing and all. Okay, you should not confuse. Keenly you have to listen. Multiplexing. Multiplexing means sharing resources. You know what is sharing resources. Okay. So now this resources will be shared by the operating system, or we can say these resources will be allocated by the operating system to other resources by following any one of these two methods. One is, here it is written in time, in space, but it is that's called time sharing and space sharing, or otherwise we can say time multiplexing or space multiplexing. Multiplexing is two types: time multiplexing, space multiplexing. Okay. What is time multiplexing? During time multiplexing, what our operating system will do? Okay. During what is time multiplexing? CPU's time. CPU should do many work. Our processor should do many work. Okay. What many work? Arithmetic, logic, computation, signal, read, write, signal passing, sending the address. What is sending the address? Suppose you are executing the program. Okay. The program is split into many instructions. Okay. Those instructions will be stored in ROM, read-only memory, because those are permanent instructions. Should be stored permanent. Okay. So then each and every instruction will be stored in ROM in particular address. Okay. Instruction 1 will be stored in so and so address of the memory. Instruction 2 will be stored in so and so address of the memory. Okay. So those addresses will be sent by the processor. So what I'm saying, processor has so many work to do. Okay. So the CPU's time, the processor time, should be equally shared by multiple processes. Please listen. CPU, this is time, no? So remember CPU's time. Okay. So CPU's total available time will be shared among multiple processes which are currently there in the system. For example, currently 5 processes are there. Process 1, process 2, P1, P2, P3, P4, P5. So the total CPU time should be shared among those processes. So process 1 can use the CPU this much time. Process 2 can use the CPU this much time. Okay, to do the processing. So during the multiprocessing, the time of the CPU will be shared by multiple processes. That is called time sharing multiplexing. That is called time sharing multiplexing. What is space sharing multiplexing? Memory, or space means memory, no? Okay. Disk also has memory. Okay. Our main memory is also memory. So memory or disk space will be shared among multiple processes before executed by the processor. That's called space sharing multiplexing. Time sharing multiplexing, space sharing multiplexing, or time multiplexing, space multiplexing. Time multiplexing means CPU's time will be shared by all the available processes. Space multiplexing में the memory or the memory space or disk space will be shared by the multiple processes before the processor, that means our processor executing the processes. So before executing the process, where the processor will execute, processor will take the data from the memory and then it will execute. So before the processor executing the instructions, that will be stored in the memory. Okay. When multiple processes are there, how it will be stored? Again, they have to share the memory. So memory sharing is called space multiplexing. CPU's time sharing is called time sharing multiplexing. Remember. Okay. Okay. Now, so now this is about the processing, but here we saw when we have to know about all these components. Why? Because the operating system is dealing with all these peripherals. No, getting it? So operating system uses CPU, so you have to know about CPU. It is using memory, so you have to know about memory. It is using video controller, you have to know about video controller. It is using monitor, you have to know about the monitor, keyboard, USB controller. You know what is USB? It's a bus. In laptop and all, you will insert this, no, pen drive. Okay, you will insert pen drive, you will insert USB cable of mouse, you will insert this USB cable of keyboard. All those are called USB. For that, we need USB controller. Okay, and we will connect the printer using USB, using the printer cable with USB. Hard disk. What is hard disk? Any one of you? What is hard? Okay, it's a storage device. It's an external device or internal, which it will be there within the CPU or outside. Any idea?
Ma'am, yes, ma'am.
Okay, removable. We can have it as removable also, even internal. If it is internal, also it is removable. Okay, or it could be fixed also. Okay, but that's a permanent memory or a temporary memory. That's a permanent memory. What will be stored inside that? The files, whatever you are creating. You are opening the desktop, you are creating a file, ma'am has given a project. Okay, so you're creating PPT, that's the file. You're saving it. Where it will be saved? Main memory menu. It will be saved in secondary memory. That's the hard disk. Okay. So use of files will be stored in hard disk. Hard disk is very big. That means big matlab what? It has large capacity. Memory is very large. But main memory is very limited. The space is limited. Space is limited. Okay. Where we were, okay. Many processors, main memory, and disk. That's why separately they have given main memory, disk, and then printer. Printer means what? This also input output device includes printers also. About all these components, to some extent, you have to know. Why? You may ask, ma'am, in operating system, why we have to know all this? Because operating system is a resource manager, no? So you should know about the resources. Sorry, Supreet, did you say anything?
Also, ma'am, files of operating system.
I don't know. Your voice is breaking. You're saying something. Yes. But whenever we are starting the system, only the bootstrap will come to what? ROM, read-only memory. Okay. So all these are resources. So we have to know about the resources. Mainly we have to know about the processor. Okay. Now processor. What is processor? Any one of you? What is processor? Okay, it's the brain of the system, brain of the computer. Why? Because that only execution, the execution happens there. Execution happens there. Processor is a hardware or software?
Hardware.
It's a hardware unit. Okay. So execution, when we say the term execution, that is only applicable for what? Processor. Only processor can execute. Okay. Execute. There are many units inside the processor to perform the arithmetic operations and to fetch the control signal. There are many buses connected with the processor. All those are there. But how the execution will happen inside the processor, that is very related to operating system. Okay. Remember, there is a cycle for CPU to execute the instruction. Students, when I say instruction, you know what is instruction? Your program, you will write the program in any high level language, C, C++, Java, Python, using whatever it is, because you know that. Okay. That will be converted to assembly language. Okay. And that assembly language will have instructions. Okay. So those instruction, if you take any one instruction, that one instruction will, during the execution, it will go through fetch, decode, execute. 3 steps. Okay. When I'm saying an instruction is executed, you should assume that the instruction has gone through fetch, decode, execute cycle. So instruction execution will have how many steps? Instruction execution cycle, or we can say simply CPU cycle. CPU cycle has how many steps? 3 steps. Fetch, decode, execute. You might have studied this in the digital electronics. You must have studied. What is fetch? Fetching the instruction from memory, where the instruction will be initially stored in ROM, read-only memory. Okay. Your program will be there in the disk. You save the program in the disk. So during the execution, the instructions, it will be splitted into instruction and it will be stored in ROM. Okay. So fetch the instruction from memory. That is fetch. That's called fetch. F-E-T-C-H. Students, that's not there here. 1 second. But here, these are other types of CPU. But it has fetch, decode, and execute. Every instruction will be fetched and then it will be decoded and then it will be executed finally. Fetch, you know, fetching the single instruction from the memory, from the ROM. Okay. Decode. Now decode means what? Decode determine type and operands of that fetched instruction. For example, add A comma B. Okay, add is what? Add is opcode. What is operand? A comma B, variables or operands. So what the decode will do, it will determine the type of the instruction is belonging to which type, and what are the operands are there in the instruction, that will be determined. That means that will be analyzed and specified. Okay, that is decoding. Execute the process. Execute the instruction. Okay. So how it will happen? how actually this fetch, decode, and execute happen. There are some registers we can use to fetch the instruction and put it in the we have program counter and instruction register. Okay, program counter, that's also a register. That's register means memory. Okay, so program counter, students, you heard about program counter in digital electronics. Okay, so to give idea, I will play one video. Okay, so there you will understand. Students, in this video you have to understand what is the program counter. It's a memory, it's a register, program counter, and also instruction register, because these two will be there in the CPU. We are talking about the processor. Okay, wait.
Okay.
I have to could not share sound. Right? It's audio settings. Headset. 1 second. I should remove the headset. I connected Bluetooth so that I have to remove, and then I have to share. Now I can share. Mm. Mm. Okay, can you see this video file? I just play. I think I don't know, audio will be clear or not, but audio you can hear, but it's just dragging. Let's just listen. I will just increase the volume. Yes, it is in high. Now I will play.
Understanding program counter operation. A computer program is made up of a sequence of instructions. Some instructions are longer than the others. The computer program is stored in the program memory. The program memory has a limited width. If an instruction is too long, it may have to be stored in separate locations in the program memory. Let's indicate the addresses of the program memory. Instruction number 2 is a long instruction. It may take up 3 separate locations. A short instruction may take only 1 location. Let's use a robot to represent our CPU. The CPU has a counter called the program counter. The initial content in the program counter is 0. There is also an instruction register. Let the CPU start to operate. The first step of the operation is to fetch the instruction from the program memory. Instruction is fetched from program memory location indicated by the program counter. The current counter value is 0000. The instruction from program memory location 000 is fetched and placed in the instruction register. At the same time, the program counter is incremented by 1. The CPU goes into the decoding cycle. Only half the instruction 1 is received in the instruction register. The CPU is not able to execute this incomplete instruction. The CPU goes back to the fetching cycle. Instruction is fetched from program memory location indicated by the program counter. The current counter value is 0001. The instruction from program memory location 0001 is fetched and placed in the instruction register. The program counter is incremented by 1. The CPU goes into the decoding cycle. The instruction in the instruction register is complete, and the CPU executes the instruction. After completion of the execution cycle, the CPU is ready to fetch the next instruction. The next location for the instruction fetch will be at program memory location 0002. The instruction is placed in the instruction register. The program counter is incremented by 1. The CPU goes into the decoding cycle. The instruction is not complete. The CPU goes back to the fetch cycle. The fetch location will be 0003. The instruction is placed in the instruction register. The program counter is incremented again. The CPU goes into the decoding cycle. The instruction is still not complete. The CPU goes into the fetch cycle again. Next instruction shall be fetched from location 0004. The instruction is placed in the instruction register. The program counter is incremented again. Notice that the program counter is incremented after every instruction fetch. The CPU goes into the decoding cycle. The instruction is decoded. Assuming that the instruction requires a jump to instruction 5, which is located at program memory location 0008. When executing the instruction, the CPU changes the content in the program counter to 0008. Execution is complete. The CPU goes back to the fetch cycle. The next instruction we fetch from program memory location 0008. The instruction is placed in the instruction register. The program counter is incremented by 1. The CPU goes into the decoding phase. Only half the instruction 5 is in the instruction register. Execution is not possible. The CPU goes back to the fetch cycle. Instruction at location 0009 is fetched and goes into the instruction register. The program counter is incremented by 1. CPU goes into decoding phase. The instruction is complete and the CPU executes the instruction. Summarizing the CPU operation. Instructions are fetched based on the indicated location sought in the program counter. After every fetch cycle, the program counter is incremented by 1. If the instruction is not complete, additional instructions are fetched. If the instruction is a jump instruction, the CPU changes the content in the program counter to indicate the next location for instruction fetch. The program counter always holds the address of the next instruction to be executed. The operation can be summarized using a flowchart. The initial content in the program counter is 000.
Okay, students, you understand the use of program counter and instruction register, which are there in the CPU. Okay. So apart from main memory, we have many registers also. Okay. Like program counter and instruction register. So now you understand that a program counter always holds the address of the next instruction, which should be executed. Okay. It will not store the instruction or address of the current instruction. It will store address, but address of next instruction which should be executed. Okay. So this you saw because this is related to processor. Okay. Here we end our today's lecture. Okay. So tomorrow I have to see the timetable. If you have, we will see the continuation of this in the next lecture.
Okay, ma'am.
Okay. Students, tomorrow I will ask what is the use of the program counter and what is the use of the instruction register, where the instruction will be stored, and what is time division, time sharing multiplexing and space sharing multiplexing. Okay, what is the CPU cycle? Okay, fetch, decode, execute, that you have to say. Okay. Okay, you can leave. Thank you.
Okay, ma'am. Thank you, ma'am.
Thank you, ma'am.
Bye.